In this question, it is given that the surface temperature of sun, which has a maximum energy emission at 500 nanometer, is 6000 Kelvin. The temperature of star, which has a maximum energy emission at 4000 nanometer, will be. So we know that the value of maximum energy radiation corresponds to a wavelength lambda is inversely proportional to the value of temperature. So you can write the value of lambda 1 divided by lambda 2 is equal to nothing but T2 divided by T1, and Rm is to find out what about the value of T2. So we can write T2 is equal to T1 into lambda 1 divided by lambda 2. So the temperature in the initial situation is given as nothing but 6000 Armstrong, 6000 Kelvin, and the wavelength in initial situation is given as nothing but 500 nanometer. So 500 into 10 raised to minus 9 meter, and the wavelength in second situation is given as nothing but 400 nanometer. So 400 into 10 raised to minus 9. So we can find out the value of T2 over here. So we can cancel this 10 raised to minus 9, 10 raised to minus 9, this 100 and 100. So we can write this will be equal to nothing but 6000 into 5 divided by 4, which is equal to 7500 Kelvin.